All right, we're going to go ahead and get started. Hello, everyone, and welcome. Thank you for choosing to spend your valuable time with us. Today's webinar will cover FIPS 140-3 and CNSA 2.0 compliance in a single connection, presented by wolfSSL Senior Software Developer Anthony Hugh. My name is Emma, and I will be moderating the webinar. All attendees will be in listen-only mode, and if you have any questions, please use the Q&A box. After the presentation, Anthony will answer any questions. And as always, all of our webinars are recorded and made available on our YouTube channel. If you'd like to stay updated with the latest from wolfSSL, follow us on Twitter, connect with us on LinkedIn, and subscribe to our YouTube channel. Feel free to reach out to us via email at facts@wolfSSL if you have any further questions. Before we dive into the technical presentation, I'd like to provide a brief overview of wolfSSL. Today, wolfSSL secures over 2 billion connections. We have more than 1,000 OEM customers and dozens of resellers. wolfSSL consists of over 50 dedicated employees, primarily engineers. This progress is, of course, supported by a strong partner network that we are very proud of. Since the beginning, our engineering team has developed several embedded security products, including wolfCrypt with DO178 support, a FIPS 140-3 certification, and a FIPS-ready offering, MQTT up to the V5 specification, SSH v2, TPM 2.0, a secure bootloader known as wolfboot, Java wrappers and JSSE support, and commercial support for curl, and our newest product offering, wolfHSM. These offerings are accompanied by thorough maintenance and support plans up to the 24/7 level. We also offer full service consulting. Now, I would like to turn it over to Anthony to discuss FIPS 140-3 and CNSA 2.0 compliance in a single connection.
Hi, my name is Anthony Hu, and I'll be with you for the next several minutes, probably close to 50 minutes, I think. We're going to be talking about the motivation for this demo that I have today. So there's going to be a demo, obviously, but the motivation, how we're going to do the demo and the demo setup, as well as someone has their hand up. Before I continue, Emma, is there anyone in the chat that wanted to say anything, or no? I guess not. No. Okay, we're good. I'll keep on going. So we're going to talk about the demo and the demo, so how to set up the demo, how to get the code and build the code, and then we're going to talk about how to execute the demo, and then we're going to actually execute the demo, which means that there's potential for disaster. So keep your crush it. I'm crossing my fingers, but let's hope this all goes as planned. At the end of the demo, we'll talk about what actually happened and how we're being compliant with both the CNSA 2.0 as well as FIPS 140-3. And then we'll also have a quick overview of the post-quantum algorithms that are supported in wolfSSL. Okay, so what are the motivations for FIPS 140-3? So one thing that's really interesting is that our certificate, which is certificate number 4718, which you can look up on NIST's website, it has a 5-year validity. Almost nobody in the industry has a 5-year validity. Just about everyone's gotten a 2-year interim certificate. We've gone through an extra special process that gives us that 5-year validity. And you kind of have to do FIPS 140-3 if you want to sell to the government. Soon, this is basically the only thing that they're going to accept. If you're not FIPS 140-3 validated, your product isn't going to get into get through the door. Now, from a technical perspective, you know that there are going to be known answer tests and startup integrity checks. So this gives you much better security assurances of your software. So what's the motivation for following up with the CNSA 2.0 guidelines? Well, they give very, very, very specific timelines. So what you're looking at, this diagram up here, it basically tells you when the NSA and the American federal government expect you to have post-quantum algorithms in your product, when they expect to be able to start using them, and when they expect it to be default, and when they expect the older stuff, such as ECC, RSA, to be all phased out and gone from your software. So let's take a look at web browsers and servers and cloud services, because today is a TLS example, so that basically best applies to what we're talking about. So the CNSA 2.0 guidance says that you should have already at 2024 added in these algorithms as an option for usage in your software, right? And then by 2025, according to this timeline, which is in a few months, it should be the default and preferred algorithm being used in your software. And then by all the way over here, 2033, you should have phased out all conventional, what is conventional by today, all those conventional algorithms such as ECC, RSA, Diffie-Hellman, anything, all of those should no longer be used. Now, that's a pretty tight timeline. We're talking like, next year turning this on by default. So, these are really, really aggressive timelines here. So okay, let's talk about the demo that's coming up. This one's going to be really simple. If you know me, I usually like to put like some sort of open source project on top of wolfSSL to kind of show the interoperability with different protocols. So I usually use a web browser, curl as a client, and then some sort of web server as the server, and we do some sort of TLS connection. Today we're going to keep it real simple because we want to focus on the algorithms and what's been going on. So what we're going to be looking at is just the example client and the example server that comes with wolfSSL when you build wolfSSL. On the client side, you're going to have the root CA, and on the server side, you're going to have the server certificate, which gets sent as part of the TLS 1.3 handshake. That gets sent over to the client, and then the client can verify it using the root CA that it has on hand. Now, normally you have only one private key that's associated with the server. In this case, you're going to have two private keys. The second private key is called the alternative private key. And so what that, and I'll explain a bit more about that as we go through the slides. Okay, so the software versions we'll be using today are wolfSSL and the wolfSSL examples repo. So for wolfSSL, we're going to be using 5.7.2, which is the latest version, but we're using the FIPS ready variant of that release. Now, unfortunately, we're also going to have to add a little bit of a patch to that code. And the reason why is because originally, one of the, I think it was MLDSA was disabled when used with FIPS. But there was no reason for that, so we changed that. We fixed it. And that fix will go into the next version of wolfSSL, which is 5.7.4, which will actually be coming out either this week or next. So you can look forward to that. For wolfSSL examples, you just grab that repo off of GitHub. Okay, so to get the code, you go to wolfssl.com/downloads, and you'll notice that there are setup boxes and a little bit of information that we ask you to fill in, and you can then get the wolfSSL-GPL v3-FIPS-ready-5.7.2.zip file. Wow, it's a mouthful. As well, you're going to want to get that the patch that I was talking about, and that's just a pull request from 7.7.8.8. So, so you can see what that diff looks like. Whoops. By using this URL, but when it comes to actually downloading it, you'll have to use this URL at the bottom. So basically, you grab the source bundle and you unzip it, you go into the directory, you download the patch, and you rename it the file to patch, and then you use the patch command to patch the code. For wolfSSL examples, you just clone it off of GitHub. Then you go into examples and you do a git checkout at this particular git hash. Now, the git hash itself isn't all that important, but it's the one I tested at. Just about any git hash should work, but this one is the one I tested. So like I said, there's a patch involved. And if you do the download, this is exactly what it looks like. And all we're doing is it says we're removing this if statement within the include.am file. And what this does is it allows you to build for Kyber. It's really, really simple. And sorry, Kyber is the old name of MLChem, sorry. So we're looking at this is how you would build wolfSSL source repo after you've unwrapped it and patched it. We've got, so we're gonna just sort of go in there, cd into the directory. We run this command. I should go through some of these flags. So, we're enabling FIPS, and we're saying we're using FIPS ready. There are different values that can go on the right side of this depending on which source bundle you have. Some of them are v5, v3, v2. But in this particular case, because you're using FIPS ready, you need to use enable FIPS equals ready. We have this flag called enable experimental, and that's going to allow you to use enable dilithium, enable Kyber, and enable dual alg certs. And the reason why these are experimental is because they are not, they're still considered experimental because the API names need to change. So we're looking at, the API still uses the name dilithium, but that's going to have to change to MLDSA. And for Kyber, that's going to have to change to MLChem. So because you can't expect backwards compatibility when using these API names, we're still calling them experimental. The dual alg certs are how we're going to do the hybridization. And those are considered experimental because they are not quite they're standardized in they're standardized in the X.509 2019 edition of the X509 standard, but they are not. So for the certificate format is standard, but the interaction within TLS is not standardized. That's still in draft mode in certain standardization organizations. So the next thing you do is you just make the code. So you do a make all after configure. Because this is FIPS, this is not a normal step that you would normally do, but in a FIPS build, you have to run the FIPS hash.sh script. And what that does is it calculates the FIPS hash for you, and then copies the FIPS hash into a file, which then and because that's in a header file, you have to do a make all again to build in with the new FIPS hash updated in the code. And that FIPS hash, by the way, is used in the startup self-health checks. So whenever you use a FIPS version of wolfSSL, you're going to have a startup health check to make sure that everything is working as expected. So that includes known answer tests as well as checking the hash of the executable against this known hash. It's not a hash of the entire executable. It's a hash of what's inside the FIPS 140-3 boundary. So then you have to rebuild again. That's a make all. And then you do a sudo make install. And on some systems, not all, you need to do sudo ld config. So yeah, this whole process requires that you have root access on your system. That's very important. A requirement of this process is that you have root access to your system. Now you can do it in a way where you don't need root access, but that gets a bit more complicated in terms of the build process. So we're going to have a certificate generation application, and yeah, so basically before you build you do your certificate generation, you have to build the applications for it. So you have to go into wolfSSL examples /x9.146, and you have to do a make clean and all. By the way, X9.146 is a draft where a lot of the TLS interactions are being discussed. It's a draft standard, and the TLS interactions are being defined in that draft. Sorry, you might not be familiar. X9 is a standardization group for banking, and the 146 is just the document number. And so we use these script OpenSSL, these OpenSSL commands to generate keys, and then with those keys, we use the applications that you built in the previous step, this step here. That'll produce gen ECDSA, MLDSA, dual key SIG root cert. And then the 5 specifies that you want to use level 5, which is equivalent to, which is just the NIST level equivalency for post-quantum algorithms. There were 5 levels defined, and the CNSA specifies that you must use MLDSA at level 5 to be compliant. And so that's what we're doing. We're generating certificates at level 5. We then use OpenSSL in the 3 next commands to convert the certificates from dir form into PEM form, and the server key from dir form into PEM form. And we already have the MLDSA server key, and we just copy it over. You'll notice here that on the name of the the name of the server private key of MLDSA has the name MLDSA 87. The parameter set for level 5 for MLDSA, the parameter set is called 87. So MLDSA 87. Okay, so let's run the demo. I'm going to get the 2 terminals up. And you should be able to see the 2 terminals here. It just so happens that I have the commands for the server and the client here. And before I run this, let me go over some of these parameters. So, okay, so we're looking at the server, and this -v4 specifies that we're looking for TLS 1.3 because post-quantum algorithms won't have support in TLS 1.2, so this must be TLS 1.3. We're doing P521 with hybridized with Kyber at level 5. And P521 just means ECDHE on the P521 curve, which is equivalent in security strength to Kyber level 5, or MLDSA 87, as it's known. Sorry, MLChem 1024, as it's known. So MLChem 1024 is equivalent to Kyber level 5. And again, that's just a quirk of the transition period right now, and why it's still experimental, because we're using these kind of old specifiers. And so we're looking at specifying the server certificate, which is the one that we just generated. And the server key is the P521 key that we just converted from dir. And then the alt private key, or what you would call the alternative private key, is the server MLDSA 87 key -PQ. So this is for authentication purposes. Whereas above here, when we were talking about P521 Kyber level 5, That is for key exchange purposes, or your supported groups in the terminology of TLS 1.3. One other thing that I haven't mentioned yet is this -D here. This -D says don't do client auth. And the reason why is because in the X9.146 document, they haven't gotten to discussing how client auth will be done in terms of using these hybrid certificates. So we avoid that for now. Okay, so the client's much simpler. It's saying the same thing, use TLS 1.3, use ECDHE on the P521 curve, hybridize with Kyber level 5, also known as MLChem 1024, and then use the CA certificate that has both P521 hybridized with MLDSA 87. Okay. And this demo is done. It's not quite done. We haven't seen the demo yet. Here we go. Run the server and we run the client, and no surprises here. Let's see. I hear you for shizzle. So if you know anything about, if you know anything about wolfSSL, you know in our test client, if you see this message, that means the TLS connection was completely successful. I think there's also a message on the server side. There we go. Client message is hello wolfSSL. So that's how you know both sides got the connection going, and this was a success. So yeah, nothing did go wrong. So that's good news. Bad news for anyone who was hoping for me to be embarrassed. Okay, so as you can see, the output here is super long, super verbose, and looking for these outputs is like a needle in a haystack. But you'll have to just trust me and just know that these outputs were output in that stream of debug messages. So so it did say that yes, we're using post quantum chem on this particular group definition. So we did do the hybrid, and the hybrid, let me explain, is just the things that are being sent over are concatenated. So the P5, the ECDHE P521 public keys are just concatenated with the ML Chem 1024 public key and ciphertexts. It's just a simple concatenation. Oops. So in this, the next message that you'll see are that the alt signatures have been verified and that the peer cert was verified. And in this case, we've used TLS 1.3 extensions to create a new custom extension. So it's not been standardized yet, which allows the server and the client to negotiate which signatures are going to be verified. And so if one side isn't familiar with the idea of an alternative public key and an alternative signature, then it won't be familiar with those TLS extensions either. So there's that way to just fall back to regular vanilla non-hybrid authentication. So that's what this final message is. It's doing TLS 1.3 certificate verify. So we noticed that there's an ECC signature. The ECC peer cert is used to verify the signature, and then ECC verify is done, and then it notices that there's a dilithium peer cert as well, and that is used to do the alternative verification, and that is successful as well. Thus the return 0 on both those functions. Okay, so let's talk here about how we got FIPS 140-3 compliance. So as you might know, as I mentioned earlier, we have a FIPS 140-3 4718 certificate. So if you're using our FIPS ready, if you're using our FIPS ready code, you yourself cannot claim to be FIPS compliant. You need to go through a commercial licensing process with us. But that's about as close as you're going to get while using open source. So you've got the startup integrity tests, which is a requirement of FIPS 140-3. In authentication, you're using the FIPS 140-3 approved ECDSA P521. For key establishment, you're using ECDHE P521. For a symmetric cipher, you're using AES 256. And for the hash algorithm, you're using SHA 384. And that's specified in the cipher suite, I believe. Did we write that in there? I didn't specify the cipher suite here, but you can rest assured that that is the cipher suite being used. Because that's the one that's being used by default. So for how are we being CNSA 2.0 compliant? And that's pretty easy. It has requirements for authentication, key establishment, symmetric cipher, and hash algorithm. So the authentication requirement is the lithium level 5, also known as MLDSA 87. For key establishment, it's MLChem 1024, which is specifically called out as it needs to be level 5. For symmetric cipher, obviously AES 256, and for hash algorithms, it's SHA 384. And again, these last two are specified in the cipher suite. Interestingly, we can talk about what quantum threats are being thwarted or averted. For public key cryptography, it's always Shor's algorithm. So, dilithium and Kyber are not vulnerable to Shor's algorithm, whereas ECDSA, ECDHE, Diffie-Hellman, and ECDH are all vulnerable to Shor's algorithm. And Grover's algorithm is what beats out, it reduces the security of AES by half. So as long as you're using AES 256, you're good to go. Technically speaking, you can still use AES 128 and not be too worried about it. But the CNSA 2.0 guidance specifically calls out AES 256 as being required. Okay, so let's look at the post-quantum public key algorithms that are supported by wolfSSL. We have, I should have renamed these to MLDSA and well, no, I already have them in parentheses. So yeah, MLDSA 44, 65, and 87. The ones in blue are the ones that are called out by the CNSA 2.0. So for the other signature scheme is Falcon level 1 and Falcon level 5. Those have won the competition, but standards documents have yet to be released by NIST. And the reason why is because they use floating point in their operations. And when you use floating point, you got to be pretty careful about using you need to be really, really careful about using about specifying things in floating point. For the chem group, we'll get back to the other signatures later. For chems, we have Kyber level MLChem 512, 768, and 1024. That 1024 should be in blue. I apologize. I should fix that in yeah, that should be in blue because it is CNSA 2.0 compliant. And for the hybrid groups, we have P256 Kyber level 1, P384 Kyber level 3, and P521 Kyber level 5, which are actually just under the hood MLChem. So you might wonder, well, how come we don't have the various signature schemes hybrids listed here? And that's because there are no code points needed for them. These kind of map to TLS 1.3 code points, whereas the hybridization for the authentication schemes happens purely in the certificate and without any need for code points in TLS 1.3. Just briefly, we can talk a bit about LMS and HSS, which is a stateful hash-based signature scheme, as well as XMSS and XMSS-MT. Neither of these are appropriate for TLS as they're stateful. But what they are great for is firmware signing and software signing. And so we use them in our wolfboot product. If anybody wants me to go into wolfboot, we can do a separate seminar or a separate webinar on wolfboot and how we're using the stateful hash-based signature schemes there. And finally, we have Sphinx Plus, which has been standardized as SLHDSA. But it's got many variants. It's again not appropriate for TLS because it's somewhat slow and large. And it's a stateless hash-based signature scheme, which means there's no state to manage, which is a big advantage over the other two that are stateful. Okay, and that brings us to the end of my presentation and brings us to the beginning of the Q&A. If you'll give me a moment. Emma, can you let me know if there's any questions in the Q&A section?
Yeah, thank you, Anthony. We'll just kick it off. CNSA 2.0 is created by NSA. Doesn't the NSA kind of forbid hybrids? Excuse me.
That's an interesting question. Their attitude is that they use what's called a double layer protocol. So they'll use a TLS connection within a TLS connection. So there's two TLS connections, kind of protecting the underlying data underneath. So that's their way of doing a hybrid. It's just kind of nesting TLS connections. So they don't feel like they need hybrids. But that said, they understand that there are requirements. And theirs are not the only requirements. There are other organizations, other standards organizations, and therefore they're willing to tolerate hybrids. So they say they will never require hybrids, but if you already have a hybrid, they're willing to tolerate it. Also, that said, you don't have to use post-quantum algorithms as hybrids in wolfSSL. We also, of course, support them on their own. So we can also accommodate non-hybrid TLS 1.3 post-quantum connections. That's it from here.
Sounds good. Amazing. Are the post-quantum algorithms within the FIPS boundary?
No, they are not. And the reason why is because NIST has not yet mandated them for certification, right? So you can do ACVP testing, but there is no CMVP requirement for any of these algorithms quite yet. They're really new, right? It takes time for once the standards are written, it takes a bit of time for NIST to kind of get together the right infrastructure and documentation for getting these things going. I hope I answered your question there.
Yeah. Final question here. Are the ML, KEM, and MLDSA fully standardized yet?
That's a loaded question because of the demo that I just showed you. The answer is sort of. So the algorithms are standardized by NIST. They're released in actual FIPS documents, FIPS 203, 204, and 205. But they haven't. But they have nothing to do with how TLS is TLS is standardized. So TLS is standardized by an organization called the IETF. And what they're doing is what needs to happen from them is they need to kind of write a few standards documents and then define some code points to be used in the various TLS 1.3 extensions. So for example, if you want to use the chem, you'll have to have if you want to use ML chem, you'll have to have a code point defined for use within the supported groups extensions within TLS 1.3. The supported groups extensions appears in client hello as well as server hello. And right now, what we're using as code points are obviously not standard code points because they don't exist yet. We're just using the code points that help us that match what liboqs uses in order to show interop with the OQS organization.
Amazing. Well, thank you, Anthony, for hosting an informative webinar. Thanks to everyone for joining. I will email a copy of the webinar recording and PDF slides. You can keep up with our upcoming events, meet our team in person, read our blog posts, and get the latest wolfSSL updates by following us on X, connecting with us on LinkedIn, and subscribing to our YouTube channel. If you have any questions at all, don't hesitate to shoot us an email at facts@wolfSSL.com. We're here to help. Thanks again, and we look forward to seeing you tomorrow on October 24th for getting started with Wolf MQTT. Have a wonderful rest of your day.